Hello everyone and welcome to Module 4 of MSL Learn's Capacity Building Series, Designing Safer Junctions. I'm Saurabh Jain, Architect and Urbanist at WRI India. In previous module, we already saw how streets are much more than just conduit for traffic. They are for placemaking, they acts as open space, they also help in generating economy, etc. etc. And we also saw how to design complete streets through the example of Pelas's road. Now we already know that pedestrians form a majority when it comes to modal share, and they are also the most vulnerable street users. But did you know that Mumbai sees nearly 500 road fatalities every year in the city? And in Indian cities, more than 30% of fatalities occur at junctions. Now, this is a very high share of percentage, given that they take up only fraction of total road area. And that is why it is extremely important for us to relook at how we design our junctions. And that is exactly what this module focuses on. In this module, we will look at the detailed process of designing safer junctions. But before getting into the process, it's important for us to understand what a junction is, and we will also look at what are the typical issues at junction. In the end, we will also go through a few junctions in Mumbai, which has been recently executed by MCGM in collaboration with us. So, junctions are a very important part of streets. But what exactly are junctions? Junctions are where two and more streets intersect with each other. They are not only important from traffic perspective, but also act as important nodes in the city, which have a unique character which you and I can remember. Before we go any further, let's take a step back in time where there was not that much traffic on streets. And let's see how some of the iconic junctions in Mumbai looked like back then. As we know, Mumbai has always been a city of people where pedestrian has always formed a majority. It's a city where people mostly walk, and this image of Crawford Market Junction is a great example of that. This is Nagpada Junction from early 1900s, where statue of Khada Parsi was originally located. In early days, when there was not that much traffic, all the junctions were open, uncontrolled junctions, and it was understood that vehicles and people would navigate their way safely. Street was shared by all its users. This is HP Junction in 1900s, which had a roundabout to channelize the traffic. But as years passed, to manage the increasing volume, we tried multiple approaches. Roundabouts at many of the junctions in Mumbai were removed, signals were added. In some cases, along with streets, we also widened our junctions. So let's look at what these junctions look like today. Crawford Market Junction, which is a Grade 1 heritage structure of Mumbai, went from this to this. Nagpada Junction from human scale went to become this massive chaotic junction. HP Junction, from having a roundabout, it became this maidan where more than 3 basketball courts can be accommodated. Now, while we did this, we designed them for vehicles. This process skipped the important users, pedestrians. We made them humongous and made a simple task like crossing the road next to impossible. As a result, they became very unsafe for pedestrians. But not only that, it made the junction less efficient for vehicles as well. To understand this better, let's have a look at some of the typical issues at junctions. Now, while working with MCGM for over 5 years on more than 100 junctions, we have observed some typical issues at junctions across the city. First issue being large intersection area. One may think that large junction area may lead to more number of vehicles crossing the junction, but this example of Crawford Market Junction suggests something else. As you can see, this arm of junction consists of 3 lanes, but at the junction, it expands to almost 7 lanes because there is so much extra space at the junction. And now you have 7 lanes trying to merge into 3 lanes. When the signal is green at both the arms, there are literally 10 lanes trying to merge into 3 lanes. This ultimately leads to bottleneck at the junction and creates a lot of chaos. More junction area also means more time for vehicles to cross the junction. It allows vehicles to speed at junction, making it unsafe. It also increases crossing time for pedestrians, because of which they take shortcuts, exposing themselves to the moving traffic. The second issue being abruptly ending medians. As we can see here, the median stops much before the actual junction, which allows for unauthorized movement of vehicles and does not allow for safe crossing for pedestrians. Inaccessible traffic islands. Now, at most places in Mumbai, we have seen that traffic islands are beautified by planters, gardens, sculptures, etc., due to which they are inaccessible for pedestrians to cross the junction, forcing them to walk on the carriageway, exposing themselves to the moving vehicles. This also reduces the effective width of the carriageway. At some places, height of the island also obstructs visibility. Next issue being wide slip lanes and large turning radius. Wider slip lane allows for unauthorized vehicle movement, thus creating conflict at the junction with the authorized movement. It encourages parking, creating obstruction for vehicles taking left, also blocking the pedestrian crossing. Large turning radius encourages speeding of vehicles at junctions, making them extremely unsafe. Coming to our next issue, which is burnout or absence of road markings. Now, absence of road markings such as zebra crossing, lane markings, stop lanes, etc. leave the users disoriented at the junction. It confuses the users, creating chaos at the junction. Now, as we have already discussed before, that we have designed our streets for cars and not people, there is lack of infrastructure for vulnerable street users such as pedestrians, people with disabilities, and elderly and children. This infrastructure would consist of protected refuge areas at the medians and at traffic islands, ramps for universal access, sufficient footpath widths, etc., etc. Let's see how we can address these issues with design. Now, in this process of design, let's first understand what all data is required before actually designing the junction. Secondly, depending on issue, how can we correct the existing geometry? Then we will see how to further detail it for pedestrian safety for pedestrian safety and ease of access. If required, how to conduct a trial. And all of this we will see through the case of HP junction. Even if you're not designing all the junctions, we hope that this process will help you understand what should be expected from the consultant while designing these junctions. Please note that this is an exhaustive process list. The process can be adapted depending on scale, type, and complexity of the junction. So let's have a look at baseline data collection, in which we will look at total station survey, volume counts, signal phases, junction documentation, analysis and issues identification. Now, in total station survey, we generally do total station survey for all the junctions, but it's done only till the stop lines at each arm. It is recommended to do the total station survey at least 15 meters on each arm. This helps us to check and understand the lane alignments while designing the junction, and also helps in designing other elements better at the junction. It is important to take counts not just of vehicles but also NMT users, mainly pedestrians and cyclists. We can use this count to understand the distribution of volume at the junction as per signal phases, as you can see in these images. Here, thickness of arrow represents the volume. Thicker the arrow means more the volume. This helps in designing lane alignment and number of lanes at the mouth of the junction, and even planning for slip lanes. Through volume counts and phase diagrams, we were able to understand that the topmost slip lane as shown in phase one was used by less than 1% of the total volume. Junction documentation. It's important to document our junctions, and we can do so with the help of taking some images and video. Documentation allows you to later compare and measure the impact of the proposed design. And such aerial shots are a good way to do so. Further, we can use this data to analyze issues at the junction. Now, during site visit, we can analyze all the vehicular movements along with unauthorized movement happening on site. We can also check for desired pedestrian movements and identify conflict points not just between vehicles but also between pedestrians and vehicles. It is always good to map any street activities happening along the junction and also understand the immediate land use. For example, is it a shop front or a compound edge or public space, etc., etc. This helps in determining characteristics of the junction while designing. We already saw issues at junction in the beginning of the module. HP junction was no different. It had large intersection area, median stopped much before the junction, crossings led right into the inaccessible traffic islands which were used to beautify the junction. No proper pedestrian infrastructure was present, which created a lot of conflict between pedestrians and vehicles, reducing the efficiency of the junction. Let's see how we can address these issues through geometric correction, for which we'll look into lane alignment, median extension, slip lanes, mapping the space required for vehicular movement, reclaiming residual space, and finally checking this geometry in Autotone or equivalent software for its function. Checking lane alignment. Now, this is the natural movement of vehicles. But as we look closely, we can see that these vehicles are entering into the wrong side of the traffic. Now, this can be corrected by aligning the medians and extending them all the way till the junction. Median extension not just helps in lane alignment such that vehicles move incorrectly, but also helps in reducing the size of junction, closing unnecessary slip lanes. Now, if you remember that earlier through counts, we realized that this slip lane was used by less than 1% of the total volume. Closing such unnecessary slip lanes helps in reducing conflict at the junction and also reduces pedestrians' exposure to the vehicle. Mapping vehicular movement. Now, mapping all the vehicular movements through actual lane widths help in understanding actual area required for the vehicles at the junction. Things like dust marks around the islands are also a good indicator of extra or unused space at the junction, which can be easily absorbed within the island area. As we already saw, that extra space at junction leads to bottleneck and chaos at the junction. Now, to avoid this, we can reclaim this residual or extra space at the junction for expanding traffic islands and footpaths at the junction. This way, you have now the basic geometry ready. Now, once this geometry is ready, we can phase-wise test it on Autotone or equivalent software to check for turning radiuses and see if all the movements are happening properly or not. Once we are sure of the geometry, we can start detailing it further for pedestrian safety and ease of access, for which we will look at how to convert residual spaces into refuge islands, how to check for continuous pedestrian connectivity, providing for universal access, traffic calming, zebra crossings, and complete lane markings. Converting residual spaces into refuge islands. These residual spaces can now be converted into refuge islands easily. Given the signal timings, pedestrians cannot cross the entire street at one go, especially elderly and people with disabilities. Refuge islands make pedestrians feel secured from the vehicles, and it also makes them protected. This helps for them to calmly wait for their turn to cross the junction. Checking for continuous pedestrian connectivity. It's important to see that there is a continuous pedestrian connectivity and that the pedestrians do not hit a dead end at any given point while crossing the junction. Ensure universal access. Now, our footpaths are generally raised by 150 mm from the road level. It is difficult for elderly people who cannot climb and people using wheelchair to access such footpaths. To avoid these, ramp at every crossing should be provided to ensure ease of access for all our street users. Traffic calming for free left turns. In case of free left turns, turning radius can be tightened and raised crossing can be provided, which will help in reducing vehicle speed at the junction, thus making it much safer. Zebra crossings and complete main paint markings orient people at the junction. They help in guiding pedestrians and vehicles about how to use the junction and avoid confusion. Now, by following this process of design, we were able to identify a lot of extra space at the junction, which was then used for refuge islands and for creating pedestrian plazas. Now, such spaces encourages the use of pedestrian infrastructure and discourages pedestrians from walking on carriageway. To make these spaces more inviting for people, it is important to ensure the scale which is more relatable to humans. Height of the islands should not obstruct pedestrians and vehicles' vision. In addition to this, use of good materials is another way of making these spaces more inviting. So let's quickly do a recap of the process that we just saw. Median extension, creating for refuge at the median, curb extension and tightening turning radiuses, pedestrian refuge island, checking for continuous pedestrian crossings, providing for universal access, raised pedestrian crossing at free left turns, and creating public plazas. Now, after designing, if there are still any doubts that how this design will perform on ground, we can always test before executing. For that, we can use simple materials like paint, barricades, traffic cones, etc. Before going for permanent execution, even HP Junction went through a trial process. One fine night with 100 barricades, paint, and proposed design drawings, the junction elements were tested on ground, and this is how it looked during the trial. To evaluate the impact of the trial, before and after comparisons were also made, and after checking for all the movements for all the users, it went for permanent execution. It may not be necessary to test the entire design. You can also test for certain important elements which you are doubtful about. Like in this case, only the refuge island which was to be introduced was tested. This is another example where pedestrian crossings were tested. And in the right-hand side example, median extension along with traffic islands were tested. So now let's have a look at some of the executed examples by MCGM recently. This is how HP Junction was transformed through trial. And this is how it looks today on ground. There's also a short explainer video about this junction, link to which is attached in the description box. Further, we also did some surveys with the help of students to understand people's perspective about this new design of HP Junction. We also mapped how people were using this newly improved junction. And we also found out through the surveys that after redevelopment, more than 80% of the people who were using the junction daily found it extremely helpful and extremely safe while crossing the junction. New design has also made their experience more pleasant while using the junction. This is Nagpada Junction, which also went through the trial process. With the help of curb extension, median extension, and reclaiming residual spaces, we were able to compact the junction and properly channelize the traffic. This is how the junction looks today. Over here, by making islands accessible and providing proper pedestrian connectivity, we were able to make the junction much safer. At smaller junctions like this one, by just adding a refuge area and proper crossing, it was made much more simpler for pedestrians to cross the junction. So let's make sure that all the junctions in Mumbai are made safe for all the street users and not just cars. These junction elements like median extension, pedestrian refuge, curb extension, checking for continuous pedestrian connectivity, providing universal access, etc., etc. These are small physical interventions at the junction, but they have extremely high impact in terms of safety. So as engineers and designers, let's make sure that we provide for these safety elements at every junction in Mumbai. This brings us to the end of this module. Thank you for watching. To receive certificate of participation, I kindly request you to answer the quiz, link of which is in your messages. Please feel free to reach out in case of queries. And coming up next is our module 5 based on street response to COVID-19. So kindly stay tuned for the same. And thank you once again.